Yeah, we can start it. In the last class, we were talking about this one, list methods, and we had discussed till this, and I was talking about this one. What is it? We are talking about copying list using copy method as well as with reference assignment or as copying a list to another variable. So we had discussed this and we have just tested the output, and but I told you we'll just need we'll just have a quick discussion on this about copying a list. Okay, let's just quickly check on that. So this is very important. Even this is useful for you as interviews as well. You might expect a question on this as well. So copying, in the sense, we can generally do copying of any object in two ways right now. Especially on these data structures, we can apply copying. One is directly assigning a value to another variable. You can see here this assigning variable, copying data from another variable. That is one thing. This is just what we call reference copying. We had discussed this in detail in the last class, but anyhow, today I'll just quickly show you what happens really in memory when we do this kind of reference assignment. Means just if you just assign a variable to another variable. Okay, that is one thing. And second thing is applying copy method. What if you try to copy an object through copy method? These are the two things just we need to quickly check. Okay, let's use a paint here. I'm using paint. So now if you see this, suppose you are doing you're copying a value from already existing list. Suppose you have some list 3 equal to some list 1. Now here, what is happening? You have already a list like this, right? And you have some values inside that. Otherwise, I'll put like this is a list object. Okay, and then this has some data. Leave about what don't worry about what is there inside that list. And this has some address, something like 100 like this. Now, and this is actually what happens. This is list 1. This is already created. This is 100, and list 1 is pointing to this. Now, what did you do? You have assigned list 1 to list 3. Now, what is going to happen? What happens here? Do you think a new object is created, or what it is going to do? What your interpreter is going to do? In this case, this is just a reference assignment. This is called what? This is simply a reference assignment. In sense here, no new object is created. So when you do a reference assignment, or if you just try to assign a variable to another variable, or copy a value from a variable to, and this is just assignment. When you do this, here, no new object is created. So it won't create a new object. Okay, what it does is it's just simply what it does. In this case, what happens is you have this object, right? List 3. So in this list 3, what your interpreter do is it just copies this address of same list 1. Here, this is list 3. 100 is copied again. Same address of list 1, which is already there, that is copied to list 3. So means what here, how many objects are created? Number of objects is just 1, but you might have multiple references. So both list 1 and list 3 are pointing to the same object. Suppose now you see, I make a change here. You can see here, right? I assign list 1 to list 3. Now what I do, I modify list 3 dot append of. I'm adding some value to list 3. See here, some 10,000 or something. You can, when I add this, I added this value to list 3. Then is this going to change list 1 as well? Definitely,
Yes.
right? Yeah. So if we modify list 3, this change also impacts list 1. Why? Because here we don't have multiple objects. We have just one object. And that one object is referred by multiple references. That's all. So if you change this object with list 1 or list 3 or list 3 or list 1, anyway, that is going to make change in this one object. So I appended some value here. You can see here I appended some 10,000 to list 3. And now let's print it again. See, let's print list 1 and list 3. And now just print. You don't need to print ID here because we know both have same address. So print list 1 and list 3 and see when you add something to list 3, is it visible with list 1 as well? Just check that. That is enough, friends. Okay, right click, run this. Okay. So this is, we added 10,000. You can see this is the last object. To which one? To list 3. You can see here, this is list 3. And same thing we can see in list 1 as well. You can see here, friends. Got it, right? So means what this is, and why in this case, what when you do a simple reference, when you do a copy, that to an address copy, when you just assign a variable like this to another variable, it is just doing what, a copying address of that object. It's called just reference copy, and both references are pointing to the same object here. And we don't have multiple objects. We just have one object shared to multiple references. So change in any, you add a value to this object with the either with list 1, then that can be accessed through list 3. Or you make some change with list 3, same thing can be accessed with list 1. So this is the idea about this assignment. Another one, what is that? Applying copy. When you try to apply copy method, what happens? Simple. Here, copy, this is also copying an object to another variable. But in this case, when you apply copy on some existing object, it creates a new object from existing one. It's not like just a simple reference or address assignment. Here, a new object is created and assigned to list 4. Means what? How this is? Let me show you quickly how this works. It means in this case, when you do copy method, when you call copy method, suppose you say some list 4 equal to some list 1 dot copy. In this case, what happens? Already we have an object with list 1. Okay, this is the address of that object, and that is assigned to which one? List 1. So this is list 1, and now 100 is assigned to list 1 here. This is list 1, and list 1 is pointing to this list object. So it has some data inside that should be fine, no problem. And it has indexing, all that is fine. Now when you apply copy method, what it does this time, it don't just blindly copy this address of this existing object and assign to list 4. When you try to say like copy, then it creates another object in another new object. And all this data that is there in list 1 is copied to which one? This new object. Suppose this address is some 100, 200, sorry. Okay, the address of new object. So now a new object is created and data from old object is copied to new object. At this stage, both are identical. But once you make some change on list 4, then the changes on list 4 doesn't reflect in list 1. And similarly, vice versa. If you make changes on list 1, those changes doesn't reflect in list 4. Why? Because these are not same objects, both are two different objects. Only when we create it, at the time of creation, they might look identical. And later on, again, both are two different objects, they behave differently. Now, when you just create copy, it creates a new object, and that new object is assigned to this list 4. So you can see here, this is the list 4. Okay, and here the address of this one, you can see here. This new object is copied to list 4. Now list 4 is pointing to this new object. List 1 is pointing to this existing object. And this time it is very clearly we are seeing that we have two different objects. One, the existing one, the one which we created when we say copy method. Now suppose you see here in the code, we'll do a quick check. Suppose I updated. So you see here now, after saying copy, what did I do? I say list1 dot append of, okay, some 1, 2, 3, 4. I appended this. So, and then now what you do, you print list 1 and list 4. Okay, print list 1 and list 4. Definitely in this case, change in list 1 doesn't reflect in list 4. So you can see we are printing list 4 at the end. So the last output you can see, and before that list 1 we are printing. Now run this and see. Now this is list 1, this is list 4, right? So you try to add something to list 1, but that is not, we are not seeing that value in list 4. Why? Because both are two different objects. This is an important scenario which everyone should understand, friends. So difference between assigning, copying something with copy method, directly assigning through assignment. So in this case, new objects are created. If you do direct assignment, it's just copying address, that's all. And similarly, in this case, as we have different objects, change in one object doesn't have impact on others. Got it, right? So you can see the value we appended list 1 that we see in list 1, but that is not present in list 4. Even same thing, you try to modify list 4, that won't impact or affect list 1. So this is important scenario with respect to copying, friends. So I hope this is clear for all of you. So that's all. This is useful to you maybe in some certification exams or some interviews, all that. Okay. So that's all about this one. Next one. So we need to discuss quickly a few more methods. List 1 dot. We had discussed all this. Just need to discuss about. We did discuss extend in the yesterday's session. So reverse method, and then sort method, and then copy and copy. We did discuss clear. That's all. I think we had discussed all other methods. Reverse in sense, it doesn't just, it simply reverse a list. That's all. When you say list 1 dot reverse, it simply reverse the elements that are there in the list. Even we can do this without applying reverse method. Very simple thing. You can print out what is that list 1. Now when you run this, you can see all elements of list 1 is reversed. You can see here. All elements are reversed here. You can see here. That's all. This is a very simple thing. Now moving to the next method. So again, list 1 dot sort. If you want to sort list, simply you can apply sort method. That's all. So this by default performs natural sorting. Natural sorting means sorting elements in ascending order. Already, anyhow, we reverse it list, right? When you apply sort again, you can see there will be a change in the output. So list 1 dot sort, what is that? I have to print. I didn't print. Let me print and show you. Now, if you see here, you can see all the elements are sorted, and this is a natural sorting. You can see 1, 2, 3, 4 changed the position here. Earlier it is at the end. Now, after doing sort, it is moved to somewhere in the middle here, as per that sorting. So this is about sort. Suppose you want to reverse. Suppose you want to reverse, you want to do sorting in descending order. Then what is that you should do? You don't need to do very much here. Simply what you can do is there is a parameter. What is that reverse? And then you can say true. Okay, then in this case, it performs sort in descending order, not natural sorting. Natural sorting means always ascending order. And if you want to do it in descending order, just apply reverse parameter here and then set it to true. Then automatically you can sort your any of your data structures in descending order. Right click and run this now. Now you can see this. Definitely your list got sorted in descending order, friends. This is idea about all about methods of list and how we can add elements, how we can remove elements, how to remove duplicates. Okay, and then all this we have covered multiple scenarios, right? Then another important topic in list. So when you are working in any scenario, I mean any project or anything, something always that is there in list is what is it? Let me just show you is comprehensions. What is it, friends? We have something called comprehensions, list comprehensions. Where is this is not too difficult. Only thing is we just need to understand the functionality, how it works. That's all. These are all iterate comprehensions are nothing but a kind of iterators again, like for loop. Even this is also an iterator. Okay. So anyhow, we have multi examples here. Before I go, we do have just a minute. Let me open the PPT as well. So where is it? I have downloaded few PPTs. Okay, let me finish this introduction, all that. Then I will open that. Okay, if time is there, then I will open PPT as well, which is shared by Shiva sir. We'll also see what other scenarios are covered in that PPT as well. What is a comprehension, friends? And if you ask me, is it really needed? Yeah, there are two things, friends. You can implement code without even comprehensions. That is one thing. But uh, right, what is the power of Python? Libraries is one thing. Okay, fine. If someone asks you, what else is one of another big characteristic of Python? Less writing, less code, friends. Comparatively to Java or C Sharp or other languages, we write less code in Python compared to other languages. Not completely very minimal. We need minimum amount of code, minimum lines of code. But difference is we can make it much more shorter, much more optimized in Python. That is the power of Python. And to achieve that, one approach is, see, if you want to just simplify your coding, you can just apply comprehensions. When you add comprehensions, automatically you can optimize a lot of code. This is one of the greatest use of comprehensions. Okay, so that is fine. So next one. So what is this comprehension here? Comprehension is nothing but compact coding. We just write some 4 or 5 lines of code in just one line. So that is what comprehension is. And I heard even from Shiva sir for data engineering, for data engineering as well. You guys use a lot of comprehensions. Not only data engineering, in any other, even on automations, what I do regularly, we use a lot of comprehensions. Right? It is all experience, friends. So fine. So it's just a compact coding and syntax look like this. What is it? It's a simple thing. Just that some variable equal to, you have to put square brackets. Wherever you see the square brackets means you are applying some comprehension. And you just need expression and iterator. That's all. This is very basic syntax. Generally, in any expression, you have 3 parameters. Minimum, we need 2 parameters. This is a very basic one, right? So, for example, this is the simple syntax with just 2 parameters. But if you ask me the exact syntaxes, it can take 3 parameters. You can see here. It takes expression in sense a simple logic. Iterator already, iterators, friends. We applied for loop number of times so far. That is it. That itself is an iterator. And condition is something we applied number of times again. Whatever we applied in bits and pieces, we just bring all that together. That is what a comprehension, simply speaking. Right? We have one piece there, we have one piece here, we have like that. And we combine all those pieces into a single piece. And that becomes comprehension. I think that's all. If you are really good with regular coding, then converting into a comprehension is not really challenging. It's simple. Okay, let's start one by one here. So this is the very simple syntax here. What is that? Expression iterator. So what do you do? Applying squares of first 10 digits from 1 to 10. So let's take a small example here. So now what do we do is we close this. I did share this with you, right? Let me copy and paste to you. I'm sharing this with you, this code with you. If you whoever thinks it is useful, just copy it, friends. Okay. These are all simple things, not a big issue. Okay, next after that, what do we do? So list handling in this, right click and then new, and then Python file, and then what do you do? List underscore comp and so enter. So this is, right, there are multiple syntaxes for comprehension. Now you can see here, one simple syntax is this, friends. Okay, very basic expression and iterator. Just follow the syntax first. And we already know how to implement a comprehension. We'll just apply it in two ways. One is applying squares. See here, applying squares of first 10 digits from 1 to 10. Suppose you don't apply comprehension. First, we just do it in a regular style, free style of coding. Sorry, friends. Then if you convert it to comprehension, you find it very simple. Right? See, even this is not difficult. Finding, applying squares of first 10 digits. What is that you do? You just apply a for loop for some val in, so you can choose range function, range of how many values? First 10. So then start is 1, comma, end is 11. Okay, colon. So this gives you numbers from 1 to 10. And then what do you do? Simply you need squares, right? Then you can just say squares equal to val into val. This is a very simple logic, friends. Okay. So that's all. So what you have to do? You have to simply print what is that? Squares. This is what we do. Suppose we are in list topic, right? Suppose we are in list topic. If you do this, this generates this iterator generates numbers from 1 to 10, and with that we are creating squares. But what I want is I want all the squares stored somewhere. Suppose if I run this, what happens? I get squares from 1 to 100. But here these are just, what is that? We are just continuously updating this variable squares. So suppose if you print squares outside, I don't get all squares. I just only get the last square updated. You can see here, we just get 100 at the end. Now what about previous values? I lost all those previous values. Now I want to store them. I want to capture all that values. Then once this is something we regularly do in our day-to-day development. When you are working on some data and you generate some outputs, and you have to capture that data. In such case, you definitely take help of data structures. Either this list is definitely one such thing, or some dictionary if it is a key value kind of thing. So what do you do? Take a list here. So then squares list otherwise. Okay, I just say squares underscore list equal to an empty list. This is okay. Now every time you iterate, you are generating squares, right? This square I want to store. Then simply what I do, I just come here and then what is that? Squares dot apply append and just pass squares to this append method. Now What is this? If I print square list, even though the iterator is execution of iterator is completed, still I have all those values appended to list. Now, if I can extract those squares from the squares list. Right now, you can run this and test it. Now you can see here, all that squares are preserved in this squares list. Right? This is what generally a scenario which we can apply for generating squares and just storing them into a data structure. That precisely here list. Now same operation, I want to do it with comprehension. These kind of things we can shift it to comprehension. Then how do you apply comprehension here? Comprehension, simple, right? We apply the very simple thing, just some, we can just again say squares list 2 equal to use this one. Now what I need to print your logic. Logic means what? Value into val, right? So whatever is there, that you put it in place of expression. See the syntax here. Expression and iterate. That expression is this value into value. And then what is that I should do? I should apply iterator. Iterator means same thing. For value, I can just copy this. See how simple it would be and put this here over. Now appending to list, I don't need to do that, because when I just put all that in this, I mean list comprehension, and I do that all that in list comprehension, automatically these, whatever the result this expression is generating, they get added to the list implicitly. Now what do you do? Sorry, just copy this and paste it here and print list 2. Now you see same thing. You can see whatever we are doing here, that logic and that iterator, we just add it to comprehension. Now this and this are same, but only difference is here. To do this, we are seeing at least some 4-5 lines of code, and that 4-5 lines we just converted to a single line with what? Comprehension. Now right click and run this. Now you can see we get the same output with comprehension as well. But the difference is, which looks shorter and simple, friends? Definitely this one, right? So, but only thing is, to get to this level, first we should have a clear understanding at this level. When you are able to do this, then automatically you can create this. That is the only thing, friends. Is that clear? So this is idea about a simple way of creating a comprehension. Fine. Next. So I hope this is clear. Let me share this code with you again, so that we can move to the next topic. I mean, next scenario in comprehension, not topic, scenario in comprehension. Okay, next after that. Now you can see another syntax. This is a very basic syntax, expression and iterator. But in a typical comprehension, we have expression, iterator, and also condition. You got it right, friends. So just a typical comprehension has, list comprehension has these 3. We have expression, we have iterator, we have condition. Of course, if you want, you can have multiple iterators also. You got it right. So it's not like, definitely you should stick to this. You can have 2-3 iterators as well in this, 2-3 for loops, a for inside, for like that, what we do, right? A similar thing we can also add it in in this comprehension. Got it right. So let's apply this one, this style 2. We just tested a basic comprehension with just 2 parameters. Now let's apply this another style of comprehension with 3 parameters: expression, iterator, and condition. Okay, again this time generating even numbers with comprehension and storing it into a list pack. You got it right, friends? So how do you do that? Simple. So let's take here. Again, we are applying one more scenario. What is it? Generating even numbers or odd numbers with a list comprehension. That too using all three different parameters, expression and iterator and condition, everything. So what do you do right now? Let's create one more Python file. Sorry, friends. New Python file and then list comprehension. Okay. Just here, what is that we do? Now you know the same thing. We can generate even odd numbers with the iterator and then all that we did some time back. Let's directly apply comprehension here. So generating what is that? Even numbers from 1 to 10 or 1 to 20. It's up to you, friends. So how do you generate it? Sum even list equal to just it's a one shot this thing, friends. That's all. So it's a one line statement. What do you do here? You just need to print even numbers. How do you print? Just print some I or something here for I in, okay, some range of what? Some 1 comma 11. Suppose if it is 1 to 10. If it is 1 to 100, put 101. That's it. We don't have a big problem here. And then what else? We can just, we need, because I need all even numbers, right? This just gives me a list of numbers from 1 to 10. That's all. I want to filter here, apply a filter. That filter is getting even numbers. So what is that I should do? If I percentile 2 equal to 0, that's all. Apply condition. Same thing we can do it in a regular or freestyle code. What do? We apply iterator and just do a validation and then print that I, that's all. That printing we are just passing here. Instead of printing, we pass it to the list so that all that values are captured by the list, are implicitly appended to the list. Now you print this even list. See here. So print even underscore list. Okay. So now what do we do? Right click and then run this. So you can see here, right? You just got all that even numbers here. This is another kind of comprehension, friends. Right, where we applied three different parameters. What is that? This acts as this expression in sense. It's not like you must write some logic here. It is a place where you pass a logic or some value or anything here. Right, and then iterator and then condition. So this is another style of implementing comprehensions. Right. Next, what else?
Manu, out of these three parameters, which parameter is executing first? Expression and iteration, and third one is condition, right? First is executing iteration.
Correct. It starts with iterator. Whomever it is, I am not seeing
Yeah,
name
go
here.
with.
Go with it starts with iterator. So
And
even
then
if you want to do
condition.
this or this, first it should start generating values, Govin. So it starts with iterator and then applies condition and then this value is appended to the list. Is that clear? This is the order of execution. So suppose you see here, let's debug it because you put this question. So debugging gives you a detailed analysis. Now you see what you can do here. See here. So what's happening? It is not showing anything. It starts with
0, right?
So it starts with 1, not 0. You can see here. Actually, it should show us values, or else we can also see somewhere in the thread and variables. Okay, we do one thing. Let's start here. You can see here. Can you see here this one?
Yes.
The console window. This is you can see the values that were internally creating. I is set to 1 here. Can you see that, Govin?
Yes, 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 ma'am.
Now it started means if I is set to 1, it started with what iterator now. Okay, then what happens? Now you are seeing here the change. Okay, it's checking now. First, it what happens? It starts with the I and then apply a condition and then append that result to the that list. This is the flow of execution, Govin. Even if you are not seeing that, let's apply 3. The condition check and appending, it is not showing. Maybe let me show if it is giving us, it is only showing I here. Generally, we can see the value list here. Then it's okay. It's fine. No problem. So then next one, it comes to 4. That's what happens here, Govin. So maybe if you want to know the order, it's iterator first. Okay, because without iterator, you cannot start get that generates values. Next one, second thing, checks condition. Maybe let me you write a clear steps here. Third one, evaluate or execute expression. Expression can be a logic or some variable we are adding here. So these are the steps that are applied on comprehension. Go. Is this clear for you?
Yes, yes.
Yeah, because in this whatever the debugging we are doing, it is implicitly doing the check and appending it to the list directly. We are not, it is not visible here anywhere. Even in the variable window also, it is showing only for this one. Okay, we'll do one thing. Let's continue till the end. Okay, 8, 9, 10. Of course, it stops after this. Okay. Now you can see here. So these are all something that created as a part of your this thing. These are supporting variables. Okay, and these are called magic, of course. Yeah, this should be fine. Now in the console, maybe not here. You should see the output here somewhere. Yeah, we are now at, now you can see after complete iteration, it is generating a list here. Can you see here? All that elements which got sorted or filtered. Now it is showing in list after completely iterating this list here. Now after that, maybe when I print this, we didn't print this right. So when we print it, what you can do again, go to debug window. Then you can see the output in the this one, and also anyhow execution by this and time had been completed. So this variable window got closed. No problem with that. But this is how you can do it, friends. So what you can do is you can keep an eye on this variables window so that you get an idea at memory level what variables are created and what changes are happening at memory level, all that. Right? This is simple idea, friends. So, and the order of execution would be like this, as Govin rightly pointed here, what steps we have here and how the order is applied. This is the order. So this is all about what a simple idea about this comprehension. What is that? Generating this even or filtering even numbers. Got it right. Next one. This is another style again, third style. You can see here one more style of comprehension. We tried two styles, just a very basic style, an expression and iterator. Condition is optional. At least minimum two are important. Third is optional. Even if you don't put condition, nothing happens. But these two are important. At least expression and iterator must exist in comprehension. That is fine. And this is with what we discussed now. And third style is this. What is this? If you want, you can also have this. But again, this is also nothing but extending style, this type 2 comprehension. So here, what is that? We are doing some checks, some true expression if condition. We are just applying some condition checks here. Right? It's like validating certain things by applying an iterator here. So this is also possible. Another syntax. What is that? Expression and then condition and then iterator. You can interchange these parameters here. Condition and expression. I mean, sorry, iterator. This time, what is that? There is a change, a slight change in the syntax of comprehension. Expression is there. A Boolean expression you can pass. Fine. And then a condition check. And then what is that? This, what is it here? Iterator. It's up to you, friends. Okay. Now you can take same simple example here. What is that? So we are creating a list comprehension, creating a list, new list based on some condition. This is what we are following. So we are just passing some expression here, and we are just iterating some, what is that? We are applying some iterator here, number in numbers. Okay. Here you can see, maybe you might ask, you might think, wondering, where is this numbers coming from? Here, you can see here. You can also take external collections and you can also pass it to the comprehension. It's not like we should always generate elements through range function. It's not like that. There are scenarios where we have dictionaries, where we have lists. We need to sort them. We need to filter them. We need to do this kind of data changes, data manipulations. Right? In that case, we do have what is that existing data structures or existing objects. On that objects, we can apply comprehensions. Okay, just let's quickly test this now. So this is another style of comprehension. What do we do? Copy this, or we can write it ourselves, not a big deal. So this is style 3 of comprehension, where I just have, so list underscore comprehension 3, enter. So just take a numbers list, something like numbers underscore list equal to, just take some numbers just for understanding. Later on, you can apply your own this thing on, or you can take your own scenarios and practice. It's okay. Now, what do we do? This is a list, right? Yeah. Numbers list. Next, after that, just apply comprehension just to generate that style 3 comprehension, syntax of comprehension. So what we are doing now? So some even list equal to, what you can do is you can apply square brackets, and then what do you do? You can first you can start applying iterator for number in numbers. We have already numbers declared here, colon. Now you have to check here if so number percentile 2 equal to 0. Then what is that? We can pass number. So we can say something even this one, else double quotes we can just pass add. This is one thing. You can see here. It's, what do you mean by this? It's kind of applying. So it's like if number percentile, if this is true, then it's, we are passing even, else we are passing odd. That's it. Now this we have to add as a value. We really need this. Just a minute. We can just directly stop here. You don't need again appending. That is not needed. So let's run this now. Copy this and paste it here. And this is like applying a ternary here. This is a kind of ternary operator, friends. Whatever you are applying here. So, right, ternary operator, question mark, colon. If something is true, execute something after question mark, after else after colon, right? It is almost something like that in Python. Okay. So just append even if this is true, else append odd to the list. That is the meaning of that. And then just apply an iterator. That's it. So now what do you do? Just print this even list. Right click and run this. Now you can see here, depends on that number position, you get that if it is odd or even, and you are collecting all those things here. That status. Okay, we are having the status here, even status and odd status, and this is a kind of ternary operator we apply along with this. Which one, friends? Along with comprehensions. So this is one more scenario, one more style of applying comprehensions. Okay, right. Next one. This is the idea about different styles of comprehension. Okay, so next, maybe we can try with more scenarios. Let me see if I can come up with share more scenarios with you. We can try on that. Actually, we have nested loops inside a comprehension, all that. We'll see that. Next one, another scenario is this, friends. So what is that? Nested list and flattening a nested list. So there are different ways of flattening. It's so simple. And also I would like to share few scenarios that is useful for you. Right? What is that? About validating different types of objects in a list, all that. So let's take this now. So, but these are all standard approaches of doing this, friends, with comprehensions. This is the idea of comprehensions. But what we do is we'll do one thing. In the coming sessions, in future sessions, wherever we can replace that regular code with comprehensions, we try to do that. It's not like we just end this journey here of comprehension journey here. Let's not just make it as a namesake discussion, but let's keep on using it, applying it wherever I think we need comprehensions in our future coding. Got it right, friends? So anyhow, I'll show you how to simply again how to apply comprehension in scenarios where we need that. Okay. Now this is another one, friends. Okay. So this is a nested list. This looks like this. You can see. Now we need to do flattening. So how do you do flattening of a nested list? Simple. There are different ways. Suppose you need to do programmatically this flattening. How you are going to do this? So this is another scenario for us. Okay. So now let's take this. This is the input. That's why I'm copying all this, friends. What do you do? Nested list and flattening. Okay. Now put it here. Same thing you can also achieve this flattening with what? With comprehension as well. So whatever we do with a regular freestyle code, you can achieve this with the comprehensions. Okay. So first let's flatten this first, and later on again apply a comprehension. That helps you to understand how to do this, how to keep applying comprehensions. From here onwards, everywhere you can apply at least in majority of the cases you can apply comprehensions, friends. Okay, flattening, general flattening, how you can do it? It's a simple scenario, right? Iterate this list. But one thing is important. If they are scalar objects, scalar means something which are not collections, which are not objects. I mean, sorry, data structures. Vectors means all data structures like tuple, list, string. Those are vectors where we have group of values. Scalars means just independent values, something like this, 1, 2, 3, 4 or something. When we iterate it, just getting each of these is fine. But when it is list or dictionary or tuple or set, then again we need to do another what, friends? Another iteration. Iteration on top of iteration. You got it right. So this you have to do a quick validation here. Right. When you want to, if you want to flatten it without applying any built-in methods or something. I think to flatten, I think we have some methods. Maybe we can just check it later. But if you are doing this with coding, what is that you need to do for some val in this one, list one. Okay, this is fine. You create another list, a flatted list. Okay, just take a name flatted list, and then I say create empty list here. This is what we do generally in development. Whenever these kind of requirements are there, first we always first create this empty lists or empty dictionaries. Okay. Very rarely tuple we cannot create empty because we can't append data to tuple directly. But we use tuples. Maybe once we have list or something, dictionary anyhow, even dictionaries sometimes, we convert into tuples internally. Right. This is a flattened list. Okay, fine, no problem. So what is that? If all elements are scalars, means independent values, then we can directly append it to flattened list. But we have some of these are nested lists, so we should again iterate them to flatten. Flatten means no more nested lists. Everything should be looking like independent values like 1, 2, 3, 4 or like this. So what do you do right now? So here we know these data hardly we have how many data types? I mean, data structure data types: list and set and dictionary and tuple. Most popular data structures in Python. And when we look at data, we understand that this has a list here. So if it is a regular one, so one validation you should do is if type of val. You can use type or is instance. There are different methods, but we didn't yet discuss OOP. So I am choosing type equal to list. Right? We have list here, right? While iterating, some of these values would be list here, list objects. See if it is list, what is that? Then again we should do one more iteration here. In again, an internal iteration is required to flatten this nested list. If it is a list, what you have to do? Simply what again? You have to again apply same scenario. What is it? You copy this. Now you can also change this to comprehensions. Okay. Whatever we are doing here, the scenario we are applying, you can achieve all this with comprehensions. What you do is I'll just give it as assignment for today. Tomorrow we'll discuss without any doubt. But today you try it as assignment. Don't again go for ChatGPT or Google Friends. Try it yourself, friends. Spend some time. That builds idea, even if you don't get the result. So that's how you have to improve your skills, friends. Okay. So anyhow, so what is that val to in val? Right. This val itself sometimes might be a list or something. In such cases, what is that? So you have to again iterate that, and then what is that? Append those values to flattened list. Dot append. Let me just a minute, friends. It got stuck. Alright. Yeah. List colon. What is that I should do? Copy this. If if it is a list, what is that? We are iterating it again and then appending those values to whatever we are getting here. Type of val equal to list. Okay, no problem. Copy this, put here. Of course, iterator is important, and we have to apply this iterator on val. If that val is list, then what is that? Apply val to in val, and then just push this inside, and then just add append this val to this flattened list. Okay, this is one thing. Else what? If it is not list, then you can directly append all this. Just copy this and just add it here. I don't think in this case we even need this else part. Okay, we can directly, I think we can add it here. Let me just try this. A bit of optimization again, because if this is a list, then it does this iteration and then flatten that list. Else directly just append values. So Okay, there might be a possibility again adding that. Okay, fine, else should be fine here, friends. Let's apply else. Yeah. So now, and here, what is that? I should directly pass val here. If it is not list, then they are just scalar values. So that means independent values so that we can pass them directly to the flattened list. Finally, what you have to do? Print what? Flattened list. Okay, run now. Perfect. See, do you see all these elements got flattened? You don't see anything nested or anything. So this is something what nested list is, and how do you flatten it, all these friends. Okay, this is one scenario. Same thing, rewrite this same code. I'm sharing this with you. Rewrite this with the comprehension. What do you do right here? Rewrite same thing with the comprehension. So this is something which you should do today. And don't use any external help. Try it yourself because you know you got this clearly right there. You got all this syntaxes clearly. Using that, give a try. And anyhow, I will also again solve this. It's not like we just leave it like here. Because from here onwards, wherever we need comprehensions, we try to apply comprehensions. Okay. Rewrite the above scenario with the comprehensions. Okay. So this is one thing. And one more important scenario. Okay, this you give it a try. If not, we'll do it tomorrow. Not a problem. So another important is you can take same thing. Okay, you can take the same data, and I'm just making it as a list underscore nested list validation. Put here. Sometimes in real time when you are doing development, we come across these scenarios. We don't just have only lists. Sometimes we might have some sets as well, something like this. I'm just putting a set as well. So you might have a dictionary as well sometimes, especially when you're processing JSON files or XMLs, you need this scenario. Right? Of course, we can convert it to some kind of list like this and we can process it. That's fine. But when you have data like this, you need to do certain validations. And if you should do validations, what is that you do here? You should check what type of data is present in this list. Now this problem statement is simple. So we have to create a list here. What is that? Problem statement is create list. What list? So according to data. Suppose if it is integer, all integers should go to integer list. All list go to list should go to list, and all sets should go to set list, and all float should go to float list, and string should go to string list. Boolean should go to bool list. Like that, what is that? Requirement is create list according to data or filter list according to data. Okay. So this is interesting scenario, right? So what is that you have to do? As per this data, we have integers, we have lists, we have set, and we have float, and we have strings, and we have boolean. You have to create 5 different lists here. So what is that? Some is integer list. Okay. This is something useful to you when you are working with data again. And that too, data engineering, these kind of scenarios, at least any similar scenarios, use will be there. So what is that you do? You can say integer list or int list, create empty one. Similarly, create 3 or 4 lists like this. So what is that you have? You can do float list. Okay. And then what is that you have to do? One more is a list of lists. Okay. Next, one more is again string list. You have to create something like this, friends. And one more is Boolean list. So now what is that? You have to validate data. This is actually a skeleton of the code. Now you validate it and then if check if it is integer and append to integer list. Check if it is a list, append to list of lists. If it is a float, append to float list. If it is string, append to string list. If it is Boolean, append to Boolean list. You got it right, friends. Again, after this, once you do this, this is step one. Rewrite same thing with comprehension. Try to again rewrite it with the comprehension. This is another. I am just only giving you skeleton for now because we are almost okay out of our time today. But we revisit these topics tomorrow. So idea is mastering comprehension. So for some time we try to keep adding all this. You got it right. So this is the skeleton. I'm just only giving you skeleton. By tomorrow, by the time you come to the session, friends, I'm not saying you should, it's not mandatory, but it helps you if you can give it a try. That's all. Okay, I'm not forcing or pushing. Okay, let me do one thing. Share this with you. So I gave you a skeleton. Fill that skeleton by tomorrow and also add this is implement two scenarios, freestyle coding and then comprehensive coding for both of this, whatever we did today, whatever we have discussed today, not this one, for this one as well. Flattening, for flattening apply comprehensions, but a small humble request is give a honest try, sincere effort, put the sincere efforts without taking help from chat gpt or which one friends chat gpt or stack overflow. I don't mean that you should not take, but you as you are in the beginning stage budding, for me it's okay because I already have that idea. For me, getting chat GPT or stack overflow is fine because I built that process. I know the approach. I am doing it number of times. So for me it's fine. But when you are starting doing it without taking that help, it enhances our understanding towards this topic. That's all. Okay, friends. So we'll stop this here for today. I hope you this is another one of the very useful and interesting session among in Python itself, the whole Python. Okay, so we'll stop here, friends. Shall we stop here? So let's stop here then.